Welcome to qnawire.
So now we're going to work on problem 37 from chapter 8. In this problem, we're asked about a reaction between potassium chloride and barium nitrate, which is a precipitation reaction to form barium chloride. So we find that we have a mass of 2.45 grams, and they ask us to determine limiting reactant theoretical yield and percent yield. So first, let's go ahead and put our reaction, which is two potassium chlorides, aqueous, plus barium nitrate, which is also aqueous. And this is producing barium chloride, which is the solid in question, and calcium nitrate. Potassium nitrate. So we're given volumes and concentrations for both potassium chloride and barium nitrate. So we need to multiply those together to get moles. And the reason we need to do this is to determine which is the limiting reactant. So the moles of KCl is 1.20 molarity times volume, which is 0.0250 liters, or 25 milliliters. And we get a value of 0.030 moles. Then for moles of barium nitrate, we have the concentration of 0.900 molarity, and we multiply by 15 milliliters, or 0.0150 liters. And our moles here is 0.0135 moles. Now, we can't, in most cases, we can't simply look at the one that's smallest to determine the limiting reagent. We need to look at the ratio. So for every, we need 2 potassium chloride for every 1 barium nitrate. So we have, let's say, 30 moles of potassium chloride, or 30 millimolar. And to completely react with that, we would need 15 moles of barium nitrate, which we don't have. So this is the limiting reagent. It works out that it's the one that's smaller here, but it will not always do so, so you always need to take into account the stoichiometry. So this is the limiting reagent. Now we can calculate the theoretical yield, which is just based off the starting amounts and the stoichiometry. So since 0.0135 is our limiting reagent, we're going to start with this. So we have 0.0135 moles of barium nitrate, and there's a 1-to-1 ratio between barium chloride and barium nitrate. And then we need to multiply by the molar mass of barium chloride. So we get 208.23 grams per 1 mole. And this gives us a value equal to 2.811 grams. So this is our theoretical yield. Now the question is, what is our percent yield? So to calculate percent yield, all we have to do is put our actual, which we're told in the problem is 2.45 grams, over our theoretical 2.811 and then multiply by 100. And when we do this, we get a value of 87.2%. So we recovered, or were able to produce 87% of the mass that we should have.